Thank you. Um, Hello student, today I am going to teach you about the approximation algorithm. First of all, the approximation algorithm is name is very unique. Approximation means we are not getting the exact answer in that case, and we are trying to find out next to the optimal solution. Why do we need such an algorithm that does not give us the guarantee of the optimal solution, and we are going for an approximate algorithm? Because the class of the problem that comes under the category of NP complete, NP hard, these problems have no definite techniques or algorithm till date to get the final results, because of which we cannot for sure claim that we can find out the solution in within time using a certain algorithm. Because of that, we go for nearby results that can give us the same amount of accuracy, nearby same amount of accuracy. And since there is no algorithm, sometime it may happen that you may get the optimal solution for the problem in 5 minutes, sometime you may take the 1 hours, or in some time you may take uh, 1 day also. So depending on the variation, and there is no certain polynomial time algorithm for these type of problem, we have designed a special kind of algorithm that is called the approximation algorithm. In approximation algorithm, uh, what we do, we find out a possible solution and number of possible solution, and we check out how accurate they are depending upon the approximation ratio. So first of all, these approximation problems are used for NP and NP complete form. First, these algorithms are used to get the approximates most next nearby most appropriate, not not the most optimal solution, the optimal solution, but next to optimal solution solution. Okay, so these algorithms are used to get the not the optimal solution, but they give you the next to optimal solution, and used to solve the NP problems like NP hard, sorry, first, second, NP complete solutions. Examples are like set cover and vertex cover, traveling salesman, right? So these problems are which are considered to be the polynomial prime solvable problem. They are not, when the number of element increases, they behave like the NP problem, and we are not sure that we can get the optimal solution within given amount of time, and whether we will get the optimal solution or not, it is not also sure. So in that case, these kinds of algorithm are used. In these algorithm, we go for the number of optimal solutions, and we check out the how better they are, how good they are, and how they are close to the optimal solution. For this, we use a special terms, the approximation ratio. How it is calculated, I am going to show you. Approximation ratio. So approximation ratio is equals to max of C upon C star into C star upon C, right? And this is called the approximation ratio. Here C is the possible solution using approximation algorithm, and C star is the optimal solution. For, as I have told you, there is no certain algorithm, and somebody may claim that he has invented an algorithm with which he has got a solution that is not the best one but is next to the best one. Then in that case, how can we compare the algorithm? None of them are claiming that they are the best solution. Then in certain case we can verify that this is the optimal solution for the case. But the other algorithm, when we want to check that how the other algorithm, which are approximate algorithm, are close to optimal solution, then the closeness to the optimal solution is checked with help of the approximation ratio. The approximation ratio is equal to max of C upon C star, comma C star upon C. By looking at this, we can definitely see that this would be the greater than 0, because among these two numbers, definitely one will be the greater than 1, and we are taking the maximum of these two, so definitely that value will be greater than 1. So this is represented by the Pn, right? For the n input, this approximation ratio and the problem, and this is called the approximation ratio. And here I claim you that if the approximation ratio is high, then that problem is worse. If approximation ratio is high, approximation ratio is high, then that problem is that problem that solution that problem is that solution is worse than much worse than the the optimal. It means the approximation ratio should be less. If approximation ratio high, then it means there is much deviation from the optimal solution. And if the optimal approximation ratio is less, then it means that that solution is very close to the optimal solution. This is the concept of the approximation algorithm. Now I shall give you an example that how does the approximation algorithm works. So for that, the one famous problem I have said that the set cover and the vertex cover. So I am going to discuss you the two problems, the set cover and vertex cover, and in that case I shall show you that how does the approximation algorithm works. For first of all, I shall give you an idea that what is actually the set cover and the vertex cover. First, the set cover. Set of set of vertices of given graph, right? Suppose a graph contains n vertices, and we divide these n vertices into different subsets, and the combination of these subsets which generate the overall vertices of the graph is called the set cover for that graph. For example, I am drawing a graph here. Suppose I'm taking a set. suppose there is a set T is equals to 1, 2, 3, 4, 5, 6, 7, 8. This is a set. Suppose the number of vertices and the possible subsets are 1, 2, 3, and S2 is equals to 2, 7, 8. S3 is equals to 4, 5, 6, 7, and S4 is equals to 4, 5, 6, 8. Right? Here in this set, initially in this set, I have taken the reference of the graph, but this may be for any set also. Suppose the set contains 8 number of nodes and 8 set of elements, and we have designed or break the set into small subsets. Subset 1 contains 3 element 1, 2, 3. Subset 2 contains 3 element 2, 7, 8. Subset 3 contains element 4, 5, 6, 7. Subset 4 contains 4, 5, 6, 8. Now we have to create the combination of subset which generate the full set of the full initial set. So the possible solution here could be many ones. We can create the set as S1 comma S3. Okay, we can also create 1, 2, 3 S1 S3 S4, and besides this we can create that. Okay, but among these two solutions, the solution 1, solution 2, here I have taken a very small set with only 8 elements, so it is quite easy to check by a single check and create two subset options which are creating the complete set. But when the number of the element increases and the number of you are free to choose any subset, then it problems become very difficult to generate all possible combination and to get all the possible sets. Here the set S1 comma S combination the set cover S1 comma S3 is will create the all the element S1 S3 and S4. Sorry, the set is S1 S2 S3. S1, S2, S3 will create all the S1, S2, right? S1, sorry, I am writing S1, S2, S3. I am writing it clearly. S1, S2, S3, and S1, S2, S3, S4. But among these two sets, you will consider this one as the optimal one. This one is the optimal one, okay, because this is also a full solution, but this is not the optimal solution. This could be the solution. You cannot deny that this is not creating the complete set, but this one is the optimal. Here in this problem, as the number of element was very limited, so you could easily find out the optimal set. And the problem is that in some problem, if the solution is given, you can verify that the answer is correct, but you cannot define the proper technique with help of which you can certainly get the optimal solution within polynomial time. So in this case, when multiple solutions are present and there is no certain algorithm which can claim or give you the solution within time for every number, then in that case we compare the two solution approximation ratio. The problem for which the approximation ratio is less is considered to be the better one. So in the set cover problem, what we have chosen this set because they are limited number of element, and the approximation ratio for that will be the less than that set. So for the set cover problem, the approximation for which the approximation ratio is less will be compared with this, and the approximation ratio close to 1 will be considered as the better one, right? Now the next problem that is also solved using the approximation algorithm is the vertex cover problem. So I'm rubbing this. The vertex cover problem is the problem in which there is a graph and there are there are vertices which are connected via edges. Then we have to choose the set of the vertices which are at least which are part of every edges. Means the set of vertices are chosen in such a way that at least they are member of every edge. Okay, so I'm writing it. The subset of vertices, set of vertices which are associated with every edge of the graph, the subset of vertices which are associated with the every edge of the graph is called vertex cover. Vertex cover. I am writing the better definition, or you must write it as collection of vertices, the vertices that each edge of the graph contain at least one vertex of the set is called vertex cover. Is called vertex cover. Right? So for the given graph, we choose out the set of the vertices which are part of at every edge in the graph, or we can say the collection of vertices that each edge of the graph contain at least one vertices of the set. Then that is called the vertex cover problem. So okay, so if there is a confusion, then I am taking an example with which it would be very clear to you. So I am rubbing this. So I am taking the graph. Suppose the graph is 3, 7, 6, 4, and 5. Right? This is the graph. Suppose this is a not connected graph. Then I have to choose a set of the vertices which are part of at least every vertex. Suppose I choose 3 and 7 and 4. This is the one vertex cover vertex, and another is because 3 is part of these two edges, 7 is part of this edge, and 4 is part of this edge. Another set could be vertex cover would be equals to 1, 3, 7 and 4, and another vertex cover would be equals to 1, 3, 6, 5. Right? There are 3 possible solutions. CV is equals to cover vertex. Cover vertex. Right? Here, check out that if I include 1, there are edge 1, 3 is part of this edge. 1, 3, 3 is part of this one. 1, 7, 7 is part of this one edge, and 6, 7, 4 edge. And one member is present here. 4, 5 edge. 4 is present here. So every solution can claim that they are giving the solution for the vertex cover problem. So here all the solutions are correct, but if with the increasing number of number of edges and complexity of the graph, this also there would be multiple solution, and there you have to claim that what would be the possible optimal solution. You cannot, here I know that I can simply check the answer by taking a look of that graph, but for the large graph it is not possible. In that situation we shall check the approximation ratio for every solution, and we shall compare which algorithms is much accurate in much higher number of classes. That approximation algorithm is considered as the better one and the better than the other one. If an algorithm, we take certain examples for which we know that the what will be the optimal solution, and we run that we run different approximation algorithm on number of problems which for which we know the optimal solution. And if a approximation algorithm shows a low approximation ratio for maximum number of problems, then that approximation algorithm is considered as the better one. So I am just writing a pseudo code of the set vertex cover problems algorithm. This is the simple the same thing that I have told you are written in the algorithm, and this will be very easy to write in the exam. So I'm just writing the vertex cover approximation algorithm. That would be the simplest case of use of approximation algorithm. So this is called the vertex cover. Approximate vertex cover. Right here, do okay, 4 and 5, right? So this is the simple pseudo code for the vertex cover approximation algorithm. What we do in it, we start with the empty set E, C and Y. C is and start with the empty set C, and E dash is equals to E, where number all the edges are present, and E is the set of the all the edges in the graph. And while E dash is not empty, until the E dash set does not become empty, what we do, we start taking a particular edge, and for when we take a particular edge, you add the vertices associated with that edge into the set C and remove that edge from the E dash. After that, one by one we shall pick every edge, and if the vertex associated with that edge, one of the vertex associated with already present in that set, then we add only the new one. And after that, when all the edge set becomes empty, and finally when E dash become empty, we stop the process. So we pick one edge, and we add these two vertices associated with that edge into the set C. Like this, we keep on picking the edge till and when we are left with no more edges, we stop the process. This is called the vertex problem. And in this way, you may get the solution, but that could not be the optimal one also. So in that case, when there are multiple solutions, because somebody may start picking one edge and somebody may start picking another edge, and both will get the very different result. So because it depends upon the from where we start with. So in that case, there are a number of solutions and there is no optimal solution. So in that case, we shall go for the approximation ratio, approximation algorithm, and we shall compare that which approximation algorithm is having the minimum approximation ratio, and that would be the best one. Okay, that's all about the approximation algorithm. Thank you.